This screencast is for Elementary Ed 4300, Methods of Teaching Science. Science Matters, Chapters 1 and 2. Introduction. What is scientific literacy? Scientific literacy is the knowledge you need to understand public scientific issues. It is not necessarily a deep or expert understanding of science. Why is it important? It's important for civics, aesthetics, and intellectual connectedness. A fundamental mismatch exists between the kinds of scientific knowledge educational institutions are equipped to impart and the kind of knowledge the citizens need. This is why we need scientific literacy in our society. The book Science Matters reflects a web-like organization of science. It is built around 19 general principles. Chapters 1 through 5 start with the great ideas of science. This week we are studying chapters 1 and 2. The universe is regular and predictable, and energy is conserved and always goes from more useful to less useful forms. We will look at these further in a moment. Next week we will look at chapters 3, 4, and 5, which conclude the first introductory chapters. Chapters 6 through 9 include the physical sciences. Chapters 10 through 14 include the earth sciences, and chapters 15 through 19, the life sciences. We will cover the rest of this book through the final weeks of our semester. Chapter 1, Knowing. The core concept in Chapter 1 is the universe is regular and predictable. It introduces that science is just one way of knowing. Science is the study of the physical world. It complements other ways of knowing, providing us with different aspects of the universe. Other ways of knowing include religion and philosophy. These ways of knowing help us to have faith and understand the meaning of life. The humanities, such as art and literature, provide us with aesthetics, non-quantitative knowledge. Science is not the only way nor the best way to gain an understanding of the world we live in. Most scientists fall into 4 labels. Physics, or physicist, study matter, energy, forces, and motion. Physics is often very quantitative and experimental. Chemists study atoms in combinations. Geologists study the origins of rocks, minerals, oceans, and atmospheres. And biologists study life forms. Chapter 1, the universe is regular and predictable. The universe can be divided into an infinite number of systems, which are nothing more than parcels of matter and energy. Here are a few examples. The solar system is composed of atoms. The common energy in our solar system is nuclear. The Earth system that we live in, matter is atoms as well. Energy, external energy, is mostly contributed by the sun. We also have internal energy, which is primarily the decay of radioactive isotopes. This drives our Earth systems and changes in the Earth structure. Finally, our body systems. The matter is composed of cells, which consists of many different elements. The energy we often call calories, which is heat from chemical reactions. These are just a few examples of systems that make up our universe. What other systems can you think of? List at least one system you are familiar with and identify the matter and energy present in that system. Bring this idea to class. You may pause this if you want to write this down. We also have the idea of a chaotic system, or a dynamic or complex system. This shows sensitivity to initial conditions. In such systems, any uncertainty, no matter how small, in the beginning will produce rapidly escalating and compounding errors in predicting the system's future. The Earth and universe is categorized as a chaotic system. To make an accurate prediction of long-term behaviors of such systems, we would need to know the initial conditions before we could have any level of accuracy. In other words, it is impossible to predict the future behavior of any complex, chaotic system. Just for your background knowledge, the chaos system is a field of study primarily in mathematics that applies to the study of systems in science. From this, we get the term butterfly effect. And this says that in a chaotic system, an effect as small as a butterfly flapping its wings in Singapore may eventually make it rain in Texas. For class discussion, I would like you to come prepared to discuss this question. From Chapter 1, as you learned about Newton's laws, how did Newton's laws unite Galileo's study of terrestrial gravitation with Kepler's discovery of celestial or planetary gravitation? Please study this in Chapter 1 and come prepared to discuss these topics in class. We will also further discuss Chapter 2 and do an in-class activity.